One thing that should be apparent from reading through chapters 1 and 2, and also from the slides for Module 1, is that the Earth's climate and its atmosphere have both changed quite a bit in the 4.5 billion year history of the planet. When the Earth formed, its atmosphere was primarily carbon dioxide. Over time, life, photosynthetic life, used the energy in sunlight to create chemical potential energy in the stuff and life of the plant. And in that process, it takes CO2, carbon dioxide from the atmosphere, as well as other nutrients from the environment, and exhales or releases oxygen. That led to an increase in the amount of oxygen in the atmosphere. So that at the present time, the Earth's atmosphere is about 20% oxygen, whereas when the planet formed, there was almost no oxygen in the planet at all. That oxygen then is what enables us to chemically react with the stored chemical potential energy in the food that we eat to release all of the energy that we need to go about the business of living. So there's been a chemical evolution of the atmosphere. There's also been dramatic evolution of the climate. And you can see in the slides and the figures that the Earth's temperature has gone through many fluctuations over the history of the planet, including some very long cold periods and some warm periods. And a lot of those changes, of course, happened before humans came along the scene because we're a very recent player in the story of the Earth. So as you go through this section, I want you to think about the fact that the Earth's climate has changed a lot. It is not a very level, flat, stable, unchanging thing. Some of the natural processes that lead to the climate having changed are things such as volcanic activity, which releases carbon dioxide into the atmosphere. That carbon dioxide traps heat, making the planet warmer. Plate tectonics, the drift of the continents, rearranges what parts of the planet are covered with water and what parts are covered with land, and that has an important role in how much sunlight is absorbed and how much sunlight is reflected back into space. And that again affects the temperature of the planet. So there are a lot of natural processes, including others having to do with the orbit and the tilt of the Earth on its axis that we'll get to later in the semester, that have led to the Earth's climate changing a lot. I finished this little section with a thought experiment for you in the slides about two boats, the Stable Stella and the Ocean Motion, both of which cross the Atlantic Ocean, one of which in every different kind of weather condition has never had any sort of accident, and the other has capsized numerous times, and the people on the Stable Stella were nice enough to rescue the ship from capsizing so it could keep trying to cross the Atlantic, but it keeps capsizing. And you're now planning a big party on a boat with a lot of people, and you might be doing some party games on that boat that involve people running back and forth from one side to the other. Which boat would you feel safer on? And after you think about that question, I'd like you to think about why I'm asking a strange question about a couple of boats in a class about the Earth's climate, and think about how that scenario of those two boats, one of which is always fine and upright, and the other which has a tendency to capsize a lot, how does that relate to the Earth and its climate based on what you've learned about the history of the Earth's climate? So take a look at that, post some thoughts about that in the discussion, and we'll talk about it more as we get into the latter parts of the course on climate change.